Howdy. Just make this a separate video, I guess. We'll see how long I want to wait on my computer to see if I can combine them. I doubt we'll do that. But I decided second video, catch you up. First video, we just uh, worked from chapter one. A little technical issues with my projector interfering with my overhead cam. So that's not a big deal. So I apologize if it was a psychedelic colors on me there at the end. I wasn't paying attention to see how long I was busy working the problems. So we're ready to start chapter two. Let's go ahead and knock this out. Reviewing these homeworks. So quick over here says which of the following is an isotope of manganese 55. Now remember that's not a negative 55, it's dash 55. So let's see what we can do here. All right. So trying to read these. So if I were to write these, manganese Mn, the 55, remember goes up here. Isotopes want the same type, different mass number. It's that simple. So I'm going to choose not A, which is the same, but D, which is Mn54. Then the other have so one same symbol, different number. That simple. All right. So moving on. Nitrogen 13. So N 13, and it's asking about protons and electrons. People miss this all the time, all day, because they do the wrong math. They get confused. So always do these the same: protons, electrons, neutrons. So my protons, we're going to get off the periodic table, and that's going to be my atomic number for the nitrogen. So let me round up the periodic table. Remember, I threw one. My desk got masking tape and everything else. I'm going to just look up here. The number there is 7. All right. The number in the top right would be the charge. There was no charge indicated in this, and so it's a 0. All right, so I have 7 protons from that number. If that's a 0, it has 7 electrons. And then 13 minus 7 is 6 neutrons. Now, this particular problem asked me protons and electrons. So protons and electrons, 7 and 7. Okay. And then it says what element has the symbol K? Even if you know that answer, you go over to your periodic table and you find it. And so K is potassium. So that simple. I look up potassium, and there we go. So the potassium, aluminum. Now, metal, non-metal, semi-metal. I'm coming in here. Here's aluminum. All right. Over here's my non-metal. Over here's my metals. Semi-metals touching. Top and bottom, side to side on the staircase, even if we didn't have the coloration. But aluminum is a metal. It's a metal. Because if I show you a piece of aluminum, you say, hey, that's metal. All right. Oh, got some funky white balance going on here. Cool. Whatever. We're in first we were psychedelic, now we're in outer space. All right. All right. So now the next one. What is the electron configuration of sulfur? All right. So I find sulfur. Here it is. And I'm going to double check. Did they want the long form or the short form? And looking at these, they wanted all of these are long form. So sulfur going across the top, I've got 1s2, 2s2, 2p. I'm going to go all the way to the end, 2p6, 3s2. Then I'm going to hit my sulfur in this group. So this is the 3p's, and I got to go 4. Squeeze the 4 in so we can see it. There it is. All right. And real quick sanity check. It should be add up to 16. This is sulfur with no charge. So 2 plus 2 is 4, 10, 12, 16. So I'm going to come over here and real carefully look through these options. And the option here, 1s2, 2s2, 2p6, 3s2, 3. So C looks fine. We don't have any D's, and so those two are wrong. All right. Xenon 6s2. I feel like my word file is too short. I guess that's it. All right. Xenon here, 6s2 is barium. And it was that simple. So I literally went to the 6s2. Now I could also get a quick sanity check. Xenon is 54. Xe is 54. And 6s2 gives me another 2. That's 56. And that's barium as well. All right. So, okay. Chapter 2. That was it, huh? All right. 6 questions. I don't know if this is the newest one or if that's the old homework. Either way, not too bad. I'll close that and give me a sec, and we'll open up chapter 3 here. And did that pop up? Yes. Excellent. All right. So I'm gonna move this over, and chapter 3 homework. So again, we're going through pretty quick pace because we want to show it takes less than 2 minutes for most of these. All right, so what is the name of compound SRBr2? SRBr2. All right, let's make a quick rundown. I've got no polyatomic. SR is my positive. SR, actually, that's in group 2. Immediately see that's in group 2. That's going to be important. So it's my positive. It's going to be a +2. BR is my negative. They're across the staircase. The BR is here and SR is over here. So real far apart across the staircase. So this is ionic. But because this is group 2, I don't have to use any the ick and the us or the stock system. It's just going to be SR, which is strontium, and then bromide. And we're not going to use any prefixes because that's for covalent. So when I go through my list here, A had strontium 2 bromide. It is a +2, but that's the stock system. We don't use that. We're just going to go with regular B. Strontic bromide, that would be the ick and us. Again, we're not using that because strontium is always a +2. And strontium dibromide, that would be if it was a covalent system. So they make these a little bit tougher because what they do is they name them using the wrong system, and then they name them correctly in that wrong system. And so that can be the hardest part. Fe2O3. So I guess I'm zoomed in a little bit here. Can't write everything on my board. All right, so let's just do this one real quick. Fe and O. I find these. Here's Fe. It's in the D block. And oxygen, I got across the staircase, so that's ionic. We'll be doing ionic, no polyatomic ions. Fe in the D block. Remember, in the D block, the F block, and under the staircase except aluminum. What that's telling me is I've got to use the ick and the us. Now, usually it would give us a note if we were doing that. So we're looking at ferric or ferrous, or I'm doing the stock system, which has the parentheses. So what goes in the parentheses is the charge, not the amount of irons, but the charge on the iron. And so that's what we'll have to find. So this is going to be iron something oxide. Iron something oxide. So let's do that math real quick. 2 times, so I've got 2 irons, X for the charge, and 3 oxygen is in group 16 and wants to gain 2 electrons, so that'd be a -2 by the octet rule. And we'll set this to the total charge, and the total charge is 0, which would be up top, which we can't see on this board. But all right, so 0. So 2x minus 6 equals 0. X comes out to be 3. So this is iron 3 oxide. Iron 3 oxide, which is C. All right. So iron oxide is wrong because it's not specific enough. So B is wrong because of that. Diiron trioxide would be if it was covalent. So this is an ionic bond. So we don't use that naming system. C6H8. C6H8. All right. So carbon and hydrogen. Don't forget, you got to move hydrogen above the boron and carbon. And so they are touching. It's actually a non-polar covalent bond. So this is going to be using our prefixes. And so 6 is hexa and 8 is octa. So hexacarbon octahydride. And so that's D. Hexacarbon octahydride. C would have been H or C7. A is if it was ionic, and B would be if it was they used this, tried to use the stock system, but not only used the wrong system, but they did it wrong. Instead of doing the charge, they gave the amount of carbons, which is not what goes in there. So sodium sulfate. Here we go with sodium sulfate. Now here's a giveaway. That sulfate doesn't end in IDE. So it's one of our polyatomic ions. So sodium, I've got to memorize sulfate. If I don't remember, I can sometimes go over here and I find sulfate, and I recognize it now. It's that SO4 with a -2. And we need that -2 because sodium's in group 1. It's always a +1. And so I'll have to do my crisscross and Na2SO4. Remember, this is one of these, so I'm not going to reduce this ratio. This 4 is part of the piece. So Na2SO4, and that would be B. Okay, so coming over here, let me scroll down a little bit, or not. That's why I quit using this mouse for gaming. Let's see here. All right, and so was most likely to have the highest melting point. Oh man, melting point and boiling point. We've got ionic compounds, then we have polar compounds way down lower, and then we had non-polar. So first thing I'm gonna check for is ionic, and so anything that's ionic, like salt, jumps out. So N2O4, when I look on periodic table, I don't cross the staircase. NH3 is a polar compound, so that might be my second guess. And methane is CH4 or carbon tetrahydride. All right. And so that is a nonpolar compound. But my winner here is salt, which is way up too high on our screen. There we go. And so if I can just adjust this a little bit. There we go. Haha. Now you can see it. So that one's not too bad. So then the outermost electrons are the valence electron. That's just immediate. See how quick that is? Lone pair electrons are just when you had, for instance, oxygen. Those are the ones not involved in bonding. All right. And so then 4 electrons would be, first off, those are the ones on the inside. There we go. Free radicals when you just have one dot by itself. All right. So then the Lewis structure for NO3 negative. So we could compare those and get rid of anything that's wrong. For instance, nitrogen should have 3 bonds. If it has no charge, we can do that by the fact it's in group 15. We can do this 1, 2, 3, 4, 5. It should make 3 bonds, have 1 lone pair. Or when we come in here, we can start playing with these. And so here's the problem is we've got this negative charge that causes us some trouble. So let's go through the steps here. We want valence electrons, then our skeleton. This is my steps to doing Lewis structures. All right. Third step will be our outer atoms. Fourth step will be the central. And then the last step, multiple bonds. only if we need them, if things still aren't happy. So our count, NO3 negative. So we've got 1 times 5 plus 3 times, this is group 16, that's 6 valence electrons. And then that minus 1, you're adding an electron. So if you're negative charge, you add an electron. So this is 5 plus 1 is 6. I got 4 times 6. That's 24 electrons. Start with my nitrogen in the middle. Let's do, it turns out I have 3 oxygens. All right. And so 8 around each of those would be 24. I don't have any left over for this nitrogen. Is the nitrogen happy though? No, it's got 2, 4, 6. Remember, each line is 2. It only has 6. It needs another one. So I'm going to take a lone pair off of this one and put a double bond. Now I have resonance. I could do it on any one of these, and the whole thing has a negative charge. So they didn't indicate a charge on any of these, but let's get the right one would be A. And we can see it's the only one where the nitrogen has 8. All right, it can only hold 8, and so there we go. Bond angles in CH4. Man, CH4. All right, so this one's a little bit tougher. So I've got to figure out, this has 1 times 4 plus 4 times 1. That's 8 electrons. Carbon, hydrogen, 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 hydrogen. Everything's happy. This is a tetrahedral. If I were to draw it like that. And so a tetrahedral, 4 things around the central atom, has bond angles of 109.5 degrees. 109.5 degrees. All right. Let's see if another page here. I'm pretty sure we did. There we go. Of the following elements, which has the highest electronegativity? Boom. It's this simple. I come over here. My highest is up here at fluorine. So barium is way far away. That's way down here. Next is cesium. Cesium is the lowest electronegativity. So iron, carbon, and oxygen. Oxygen would be the highest. It's closest to fluorine. It's that simple. So electronegativity closer to fluorine, bigger. Wow, the focus is really far off on that. Okay, I'll play with that later. And then the next one, nitrogen and bromine. Okay, so here's nitrogen, here's bromine. I'm not crossing the staircase, but they're not touching. All right, so it's going to be polar covalent. What shape is the water molecule? Hopefully by now you did have that one memorized, but here's the Lewis structure for water. It's got 4 things. 4 things would be a tetrahedral. We did this one in lab enough that hopefully you remember it. But when you do the shape, you don't include these lone pairs. So we're going to erase those, and we get this shape, which is bent. So what shape is the water molecule? It's bent, and it is polar. This side is positive, this side is negative. And so that's what makes it polar, is the fact that it's bent. All right, so bent. All right. The bond found in CO is single, double, triple, or ionic. All right, so let's double check it real quick. CO, not touching, polar covalent, right? But we didn't cross the staircase. So CO, I've got 1 times 4 plus 1 times 6 is 10 electrons. 10 electrons. So carbon would be the central atom. I'm going to fill up the outside. My oxygen, there's 8 used. I got 2 left. Put them on my carbon. Carbon is still not happy in step 4. So step 5, I'm going to take a lone pair off of here, make a double bond. Carbon now has 6 electrons. Oxygen still has 8. Another lone pair off, make a triple bond. And now I've got oxygen has 8, carbon has 8, and so this is a triple bond. Carbon monoxide is a triple bond. All right. What is the formula for potassium nitride? Potassium nitride. Potassium is K. Nitrogen is N. So that'd be nitride. But here's the problem. I need to know their charges. So K is a +1. Nitrogen, by the octet rule, it's in group 15. It wants to gain 3 electrons. It'll be a -3. So then I do my crisscross, K3N. So D, K3N. All right. What is the formula for lead? So let's put that over there. All right. So what is the formula for lead for oxide? All right. See what you guys can see. Yep, you can't see the lead. Okay, whatever. We'll get over it. So I'll scoot over here just a bit. All right, so lead, I need the symbol for it. So lead is Pb, plumbum. All right. And then this 4 is not telling me a 4 down here. It's telling me a +4 up there. Oxygen is in group 16. All right, so it's going to be a -2. When I do my crisscross, I'll have a 2 and a 4, and I can reduce that down, PbO2. And so that's D. So you might see, yep, this is on there as an option, but we want the lowest whole number ratio if it's ionic. So there's my winner. Okay. Which atom has the highest electronegativity? We saw that one earlier. Is that the exact same question we saw? Barium, oxygen, iron. It's exactly the same question. So okay, the answer was oxygen. Okay. Man, talk about your easy one there. Huh. All right. So we'll close chapter 3. We're ready for chapter 4. Hey. All right, chapter 4. Oh man, we got some conversions going on here. All right, so chapter 4, 45.7 grams of CaNO3 2, and it wants us to go to moles of CaNO3 2. All right, so grams of that to moles of this. That's mine. So we're going to be looking at our Scary River picture, but we're just going to grams to moles. So we're going to use our numbers right off of here. So Ca is 40.08 and N is 14.01. But I've got 2 of these, so 2 times 14.01. And we have 6 oxygens. And that's going to be our number for our molar mass. 40.08 plus 2 times 14.01 plus 6 times 16, 164.1 grams per mole. We have molar mass. So now I can set this up. 45.7 grams. 164.1 grams is 1 mole. And off we go. So 45.7 divided by 164.1. I got 0.278 moles. And that's D. That would be D. Okay. The next one, we're going to go moles to grams. So 0.34 moles NaOH. So 1 mole on the bottom, so many grams. To get that molar mass, then Na is 22.99 plus 16.00 plus 1.008. Just getting those numbers right off my periodic table. All right, so 22.99 plus 1.208 plus 16. 39.99. I'm going to call it 40 since it's multiple choice. 34 divided by, whoa, I'm in the wrong place. That needs to go with the grams. There. Times 40. 13.6. Now, if I know me, and then I bet if I had done the division, I bet that answer would have been on there. So got to be careful. So 13.6, does that make sense? Yep, we're multiplying. So B. Okay. So then 0.23 moles to formula units. 0.23 moles. 1 mole is 6.02 times 10 to the 23rd formula units. All right, so 0.23 times 6.02 second E 23. 1.38 times 10 to the 23rd. Formula units. Is that on there? Yes. A. Okay. All right. Out of the products in the reaction of aluminum and HCl. Ooh, man. Flying along here. Aluminum and HCl. So, first off, this is an A plus BC. It's a single displacement, and it goes to AC plus B. We saw this a lot in the lab. So, if you're taking the lab, that helps a lot. And can't see it over there. Maybe you can. I don't know. Maybe the issue. You can see it just fine. The issue is just I had not a wide enough monitor to show me the preview. Okay. I don't know what it did there. All right, hang on. Give me a second. Now I can get a little preview of what you can see. All right. Excellent. So when you're doing these, reaction type, product parts, then the new subscripts. And you can balance it. And then we can do solubilities. All right. So this one, I found the parts that may very well be on there as an option, but I need to find the new subscripts. So aluminum always makes a +3. Chlorine will be a -1. And H, that's one of my diatomic elements. So quick list of those. H2O2, N2, F2, Cl2, Br2, I2. All right, so that's always diatomic. Crisscross this. AlCl3 plus H2. That's B. B. All right. So easy to miss. So I had to do a couple of key pieces of information. So you had a lot going on in that problem, but it's also right out of the lab. So no problem. Na2, Na2SO4 plus NH4 Cl. All right, I'm gonna bring that down this way. So here's an AB plus CD, and that'll go to AD plus CB. A piece is Na. Don't bring the subscript unless it's part of the piece. D piece is Cl. C piece is NH4. I only have one of those. That's part of that 4 is part of the piece. B piece is SO4. All right, so I've got the product parts. Now let's get the new subscripts. This is a +1 and a -1. That's a 1-to-1. NH4 is a +1. SO4 is a -2, so I need 2 of my NH4s. So NH4, 2, SO4, and NaCl. Hey, there it is C. All right. So then it says, what are the coefficients when this one is balanced? See if I can just scroll down. There we go. So balancing chemical reactions here. Okay, so N, whoa, Na2SO4 plus KNO3 goes to K2SO4 plus NaNO3. All right, good. See it. Let's just make a list. NaSO4 KNO3. Notice I'm keeping my polyatomic ions together. I've got 2 over here, one of those, one. Over here I got 1, 1, 2, 1. All right, so I need a 2 in front of the K. That'll give me 2 of those, 2 of these. And I need a 2 in front of the Na. That'll give me 2 of those, 2 of these. And that's it. So 1 to 2 to 1 2. What are the coefficients? So 1 to 2, 1 to 2, D. That's it. Not too bad. Okay. What are the products when CH4? Oh, burned. Well, that burned is CO2 plus water. Any kind of combustion, CO2 plus water. That's C. Okay, that one's not too hard. Oh, here we go. CaH2 plus, and they've got it balanced. Normally, I like to check that they balanced it correctly. So let's check that in just a sec. All right. 1 calcium. I've got 6 hydrogens on this side and 2 oxygens. 2 oxygens. Here's 2 hydrogens. Another 2. That's 6. All right. So it wants 141 grams CaH2, and it wants us to go to grams of H2. All right, notice those two are different, so I've got to cross my scary river. So I'm going to go grams to moles to grams. Grams of CaH2 to moles of CaH2. That'll be the molar mass. Molar moles I'm going to get from my balance coefficient. So I'll need this one and this one, which is an understood 1. All right. And so let's set that up. So we're going to start with our 141 grams CaH2, 1 mole CaH2 is so many grams of CaH2. Calcium is 40.08. So 40.08 plus 2 times 1.008, 42.096. 42.096. All right. And 1 mole CaH2 gives us 2 moles of H2. All right. So just getting this from that too. All right. So then for each 1 mole, notice it's back to 1 mole of H2 gives me 2 times 1.008, 1.09 or 2.016 grams of H2. All right, so multiplying across 141 times 2 times 2.016 divided by 42.096. I got 13.505. And let's see what we got. Anything close? We got 13.4. That would be B. Okay. Probably they just rounded that to 42 and these off to 2. So I bet I could do 141 times 4 divided by 42. That gives me that 13.4. So they did some rounding, and yeah, close up. So that one was B. Okay. Let's see what else we got. Any others here? 9. Let me figure out what I got going on here. Whoa, hello. Too big. Tell me what you want. I miss Clippy sometimes. All right, so let's come on here. Da, da, da. Okay, and there's that. Okay, there we go. Now we can see it. All right. 9. If 4.5 moles of N2, so let's get our reaction here. N2 plus H2 goes to NH3. And that's not balanced. All right. Okay, so what did they give me? They gave me 4.5 moles of N2, and it's 3.5 moles of H2. And it wants to know, what is the limiting reagent? Ooh, okay. Problem is that they didn't balance it. All right, so they didn't balance this thing. Let's see if I can make this look for and slide this. Over just a little here. There we go. Okay. And so you still can't see the N2, whatever. So you gotta learn to write over here. N2 plus H2 is not balanced. I'm gonna put a 2 in front of the N2. That'll get and a 3 in front of the H2. Now to balance that out. All right, so I got apples and oranges. I need to compare them. So I'm gonna go to moles. Take both of these to moles of NH3. Be just as easy. All right, so I'm gonna start with my 4.5 moles of N2, and for each 1 mole of N2, I make 2 moles of NH3. And then I have 3.5 moles of H2, and for each 3 moles of H2, I make 2 moles of NH3. You had to balance it. The key to this was balance. All right. So this was 9, and this is 7 divided by 3. Which one do I run out of? Well, I run out. This is like 2 something. So this is my limiting reagent. So H2 is a limiting reagent. Reagent's like reactant. All right. So that'll be A. We ran out of hydrogen gas before we ran out of nitrogen gas. Okay. Try to erase it with my mouse. That's not gonna be good. Okay. So then what precipitate forms? Oh man, we got a lot going on. This one's reach way up here. PbNO3 2 and KCl. That's a double displacement. So PbCl plus KNO3. This is a +1. That's a -1. That's fine. PB is a, let's do my math here. 1 times x plus 2 times -1 equals 0. X equals a +2. So this is a +2. This is a -1. So it's PbCl2. Now I'm going to look these up on the back of my periodic table. Down here. Here's my solubility list. Remember, it's two different tables. This top one here, soluble unless, and the exceptions only apply on that line. And these are insoluble unless. So I'm going to go through here. If it's got potassium, it's soluble, no exceptions. If it has nitrate, soluble, no exceptions. So I find down here Cl. Cl is soluble unless it's with silver 1, mercury 2, or lead 2. It's with lead, it's a +2. So this is not soluble, so it will be a solid. This is soluble, so it's AQ. Aqueous, dissolved in water. Now I'd ask which one, what precipitate? That's the solid that's formed. So PbCl2. Ooh, sneaky. All right, so they asked if it was going to be PbCl or PbCl2. It's PbCl2 is what gets formed. So remember, you got to go through your steps. We did reaction type. We did product parts. Third step I did was the new subscripts. That's where I had to come back and do this math for this double displacement. Fourth step would be to balance it. I didn't actually balance it just because I cheated new. I didn't need that. I could do that real quick. I need a 2 here and a 2 there. But it didn't actually affect what they were asking. And then I did my solubilities. So if you skipped this step 3, you'd have missed it. Okay, so got to do all those steps. All right. So then we've got what type of reaction is the following? And so I've got an A plus a B goes to an AB. That's a synthesis or a combination reaction, same thing. All right. Which of the following is not soluble in water? So I'm going to double check my list here. So lithium hydroxide, calcium sulfate. So let's see. Sulfates are soluble unless it's with calcium. That's an exception. So that is a solid. That's not water soluble. Let's see. Hydroxides are on my list. They're not soluble unless they're with lithium. So that's soluble. Chlorine is soluble unless it's with silver, mercury, or lead. Iron, it doesn't say anything about. And ammonium, anything with ammonium is soluble. So it's my only one that's not. So that's my answer. And then it says, hey, what's the molar mass of CaOH2? Well, that's not too bad. 1 times Ca is calcium is 40.08 plus 2 times my 16. Because I got 2 of those. Plus 2 times 1.008. I distributed that too. So 40 plus 32 is 72 plus 2, 74. And D. There we go. Okay. Or we can type it in, but we eyeball it. Formula mass of ammonium sulfate. Oh, ammonium sulfate. All right. So this is NH4. This is SO4. This is a -2. That's a +1. I need 2 of those. Man, sneaky, sneaky. All right, so now let's do 2 times 14.01 plus 8 times 1.008 plus 32.07 plus 4 times 16. Type all that in. I got my calculator. Here we go. 2 times 14.01 plus 8 0.008 plus 32.07 plus 4 times 16. 132.154 132.2, that'd be C. Okay. Let's see. No problem. Hey, that takes care of chapter 4. Sweet. All right, let's knock that out of the way. Let's find chapter 5. Every time I clicked it, it wants to change the name of it. I always hate that about Windows. No, I can't. Click. Mouse is worn out. All right, so chapter 5. We're rocking along on these. Oh man, I got all kinds of stuff. So I'm gonna start with my 20.9 liters, 1.00 APM, 4.00 liters. And it wants to know pressure. Okay, so this is volume, this is pressure, this is volume. 20.9 went with the 1. Those I'll put 1s with those and a 2 with this. And I'm going to go to my gas laws, and we could just directly find it off of that. Pressure and volume is Boyle's law, but I'm going to just derive that real quick. NRT, don't need that part. PV, 1s, 2s. P1V1 equals P2V2. All right. So I'm going to just the volume. So this will be 1 times 20.9 divided by the, oh no, I'm getting pressure, sorry. Is that, yeah, okay. So V2 is 4. 20.9 divided by 4, it's like 5. So 5.2 looks now. Let's see. 20.9 divided by 4. 5.225. So A. 5.2 atmospheres. Okay. There's number 1 done. Erasers giving out on me. All right. 2 says 1.25 liters, 20 degrees Celsius, 80 degrees Celsius. And what is the new volume? So there's a volume, a temperature, 1.25 at 2. Those two went together. These two go together. PV equals nRT. We're looking at volume and temperature. So it's Charles's law. V1 over T1 equals V2 over T2. All right. And so, ooh, sneaky. This is Celsius. Can't use Charles's law unless it's in Kelvin. So K equals C plus 273.15. So I'm going to make this one 293. And 273 plus 80, 353. 353. All right. So volume 1 is 1.25. Temperature 1 was 293. Volume 2 is what we're trying to find. And temperature 2 was 353. 1.25 times 353 divided by 293. 1.51. Get me close enough. 1.5 A. And that'll be liters. All right, so we heated it up and it expanded. That makes sense. Okay. All right, here we go. 30 degrees Celsius, 2.05 atmospheres. I'm just jotting down the stuff I see. 2.0 degrees Celsius, and it asked me for pressure. Let's see, this is a temperature, a pressure, temperature. 30 and 0.05, those went together. 1s, 2s. PV equals nRT. Looking at pressure and temperature, doesn't have volume. It's a weird one. That's Gay-Lussac's. All right, so the weird one. Let's do, gotta divide, so it'll be P1 over T1 equals P2 over T2. And again, need to go into, so this will be 330 plus 273 will be 303, and this will be 275. Pressure 1 is 2.05 divided, let me say, times T2, which is 275, divided by 303. Okay, so 2 times 275 divided by 303, 1.82, 1.86. Let's double check my math here. 3 plus 273. 2.05 divided by 303. 2.05. Okay, how about that? Once I hmm hmm what am I doing here? Oh, I see a problem. No. 30 degrees, 2.05, 2 degrees. What pressure? And what do I do here? 275. 2.05 times 275 divided by 303. 86. 1 point, I don't know why I got that. 1.86. Okay, yep, D. How about that? Double checking. All right. Okay, so next. So there we go over here. That was 3. That was 3. We're ready for 4. So 4. Let's start putting these numbers up here. All right. 2.5 liters, 25 degrees Celsius, 1.00 ATM. And it said all those went together. And then down here, it wants to know volume when it is 0.800 atmospheres and 20 degrees Celsius. All right, so temperature, pressure, these are twos, and make that a 2, and a pressure, and a temperature, and a volume. This combined gas law, PV equals nRT, PV divided by T equals PV divided by T 2222111 Kelvin. That's where people miss it. Got to put it in Kelvin. All right. So we can solve it first and then plug everything in, or so P1 V1 times T2 over T1 times P2 will be V2. Algebra, we got to that point. Now let's go ahead and make this one down here 293, and this one will be 298. So not much of a change there. So P1 is 1, V1 was 2.5, T2 is 293. Be careful about which one you put where. T1 is 298, and P2 is 0.8. Now I need parentheses on the bottom. 2.5 times 293 divided by open parentheses 298 times 0.8 and 3.1. 4. 3.1, and this will be liters. And you can see that 3.1. Okay, 3.1 liters. There we go. Okay. Rocking along. We're already in chapter 5, man. So we're ready for number 5. Couple of different ways of doing this one. All right, so 5 multiple ways. So there's 22.0 grams of CO2 at STP. All right, let's do it the cheating way. 22.0 grams CO2. 12.01 plus 32 is 44.01 grams of CO2 in 1 mole CO2. 1 mole of any gas at STP is 22.4 liters. And it should have had units here, but it didn't. So 22 to 10. Let's see. This is a half, and that's 11.2 liters. So that's a half times 22.4. It'll be 11.2. Let's do it a different way. 22.0 grams CO2. So I'm going to use that same 44.01 grams as 1 mole. 0.5 moles. I'm doing a little bit of rounding here. CO2. That's in. All right. T at STP is 273.15. P will be 1 ATM. PV equals nRT. So volume will be 0.5 times 0.0821. Again, doing a little bit of rounding. Times 273.15 over 1. So 0.0821 times 273.15 times 0.5. 11.2. All right. So if you remembered this number, you could. The book wants you to memorize it. Or you memorize these conditions for STP, which you got to know anyway. So I just use those in the ideal gas law. Where did I get R? Remember, I used 0.0821 because that's as a student I memorized that, but R is down here. Universal gas constant. It's right down here. All right. So the old gas law works great for that one. Okay. Then I had a mixture, number 6. So 0.3 ATM, 0.2 ATM, and 0.01 atom. What is pressure of the mixture? 0.51 ATM. That's it. Okay. Pressure and volume. Pressure and volume is boils. Temperature and volume. Charles in Charge was on TV, and so temperature and volume TV. That's Charles, and then volume of gas has the following conditions. Well, let's see what they gave me here. 1.3 ATM, 28 degrees Celsius, 2.3 moles, and they want to know volume. All right, so we got volume. There's N. There's T. There's P. 28 plus 273.15 would be 301.15. PV equals nRT. And so volume is nRT over P. Oh man, let's do it all nice and neat here. 2.3 times 8.20578 times 10 to the minus 2 times 2 times 301.15 divided by 1.3. 2.3 times 8.2 0.0578 second EE negative 2 times 301.15 divided by 1.3. 43.721 if I round that off. 43, we had 2 sig figs in our temperature and in our number of moles. They used 3 for some reason, so hey, it'll be fine. Okay. That was number 9. Okay. Is that the last one? Looks like it. Okay. Looks a lot harder than I thought it was going to be. All right. So let's see. So 6. Oh. I'm still recording. Yep. I just got a Windows notification. Okay. This is all the 6. Ooh, man. A lot of stuff in there. All right. So let's double check. Yep. Okay. 6. Let's start with number 1. Yeah. We having fun yet? All right. Molarity. So molarity. That's capital M. Moles solute over liter solution. I'm just going to write that down. I'm sure it's on my helpful equations sheet. But so this says take 3.8 moles and the solution had 1.5 liters. That's easy enough. 3.8 divided by 1.5. 2.53 repeating capital M. So 2.5 D. All right. So let's go number 2 then. It says molality. Molality is mole solute kilograms solution solvent. That's the weird one, right? That's the weird one. All right. But wait a minute. They only gave me 2.5 grams of solute because it says dissolved in, and it's dissolved in 20 kilograms. That's my solvent. 2.5 divided by 20. Is it really? That's it. 0.125. Oh no, I don't see it. 2.5. Oh, you see what I did? 0.125. But this is grams, right? That's not the right thing. Gotta have, this is kilograms. Gotta have moles. So let's go 2.5 grams. And this was NaCl. NaCl. So I'm going to take my 22.99 plus 35.45. 2.99 plus 35.45. And we'll have 58.44 grams for 1 mole. 2. It's a good thing they didn't have that. So that's wrong, right? So 2.5 by 58.44 is 0.0427. We'll call that 8. All right, and we're going to take that and divide it by 20. I get 0.00, and you guys can't read it at all. Right, 0.0021. D. That's D. Okay, so D is my answer there. And sneaky. All right. So that's why it's important you write down the definition. Even though you have it on a sheet, just write it out. Percent by volume. Percent by volume is actually this one. Mass over volume. That's grams of solute over milliliters solution times 100. All right, percent by volume of 4.1 grams of acetone dissolved in, so that's my solute, milliliters of solution. Milliliter times 100. 4.1 divided by 14 times 100, 29%. Okay. So rocking right along. What are we on? 4% by mass. Percent mass of mass. Grams of solute. Grams of solution times 100. So this is 25 grams of KBr. That's my solute. I got so there's solute. I got 4.3 liters. There's my volume of solution. And then it had 4.5 kilograms of solution. I need these two, but this needs to be 4.5 kilograms. 1 kilogram is 10 to the third grams. So I'll write it all up here. I'm going to take my 25 divided by 4,500 times 100. So 25 divided by a cheat divided by 45, and I get 0.5 repeating. 0.55 or 0.56 A. What did I do with the liter solution? Nothing. Didn't need it. Didn't need it. So, okay. I did have to go to grams. Just take kilograms over to grams. All right. So people say, hey, that fourth test, what chapter is on? Well, you needed chapter 1 to do part of that problem. All right. That was 4. We're on 5. This is ppm. All right. So ppm is grams of solute, grams of solution times 10 to the 6. All right. Grams of solute, 6.4 grams. 6.4 grams dissolved in 44 liters. Don't care about that. Mass of solution is 5,200 times 10 to the 6. All right. 6.4 divided by 5,200. You get a small number. That's fine. Times second E fixed. Remember, it's not 10. So I put, here's what I typed in my calc, 6.4 divided by 5,200. Now don't just put E. So what I did is I hit enter. And then I said times E6. All right. So a lot of people make the mistake, they put this E down here. All right. You need this to be up top. So you can either put the multiplication sign or you can just hit enter and then do it. That's what I like to do. So I got a 1231 ppm. They get 1230 is the closest. So 1230.7. So okay, 1230. So I'll take that one. That's my best answer. All right, 6. We got 6.7 milliliters. We got 2 molar. I got 10 milliliters. A new concentration. And I see this word diluted. Diluted tells me M1V1 equals M2V2. This is V1. This is M1. This is V2. And we want M2. All right. 6.7 times 2. divided by 10 will be M2. And notice I kept everything in milliliters. That's perfectly fine. So I don't know. What is that? 13.4, 6.7 times 2 divided by 10, 1.34. All right. And do we have 1.3 is C? All right. Then they had PPB. Okay. 7 PPB. PPB. Grams solute. Grams solution. Oh, I miss the days everybody had to memorize these, man. All right. And so times 10 to the 9 part per billion. Grams is solute. It says, let's count these zeros. 1, 2, 3, 4, 0 grams in 600 grams of solution times 10 to the 9. 0. I got 3 zeros, 4 zeros. There were 3 zeros and a 4. Divided by 600. I hit enter. You guys can't see that. It's way too small. And I'm going to put time second E9. So I can show that type that in. There we go. Oh, look. Evil. 666. All right. Wait a minute, but it doesn't have that as an option. So this is PPB. But notice we had this had 2 sig figs. This had 3 sig figs. So this one should be 670, no decimal place, to be 2 sig figs. And so it's the only one close, but that is also the correct answer. And so that's D. All right. Equivalents on 8. 8. Equivalents are in 1 molar magnesium plus 2. So I'm going to take 1 molar times 2, and that'll be 2 equivalents per liter. Nope, and you can't read it. Too bad. Multiplied it by the charge. Molarity times the charge. All right. Let's see if I can scroll down here. Nope. Let's see if I can do some keyboard and scroll down. 3.5 grams NaOH and 50 grams H2O, and the volume is 52.0 milliliters. And all kinds of stuff going on here. This is 9. It wants molarity. Moles over liters. Moles of solute over liter solution. Ooh, they sneaky. All right, so 3.5 grams. I'm going to take that. NaOH. So 23 plus 1 plus 16 would be 40. And so we'll call that 40 grams to 1 mole. 3.5 divided by 40 would be 0.0875 moles. Some rounding. And then volume, that's just 52 milliliters. 52 milliliters. 1 milliliter is 10 to the minus 3 liters. And so I'm going to take that. That's 0.052 liters. You could just take the 52. Nope, you can't see it. I could just taken the 52 and gone 1, 2, 3. Right. And so now I'm going to come in and I'm going to come back to this equation right here. I'm going to take 0.0875 divided by 0.052. So 0.052. And now I get 1.68. 1.68. And this one doesn't, 1 point, this is molarity, and I don't have any options written here. Apparently I have an old copy here. Haha. We don't know what answer that is. Okay. Oh man, this is a really old copy. Let me see what. Pull this up on my other computer here. Oh no. There we go. Okay, so we're in chapter 6. And this was 9. Nope, still blank. Hope I didn't upload it blank. Surely not. Ah, no, here we go. Okay, so this would be option we come up with here. 1.68, 1.68, which should be 1.7. Get rid of all this crap. 1.7, which was B. Okay. Apparently, I didn't save the Word file. I just saved it as PDF. Not a problem. All right, so 10. We've got a patient's given 30 milliliters of 2.3% more volume solution. How many grams of medication? Oh, this is massive. Let's see. So 2.3 by volume solution. So we got 30 ml. And we're going to do this. And this is grams of medication. So let's do this. Let's just write what this is. Trying to read my handwriting over there. All right. Let's do this percent mass over volume is grams of solute, okay, over milliliter solution times 100. And they told me this was 2.3. All right. And this will be 30 milliliters down here. We still got this times 100. And then we want to know that. Okay. So 2.3 divided by 100. 2.3 divided by 100. I don't know why I typed that in. Habit, I guess. Equals x over 30. And then times 30. We get 0.69 grams is our x. And 0.69 is D. Okay. Okay, so what are we on? 11. I need to take, okay, so kind of critical thinking there. You had to plug it in. Need to take, so this is 11. I need to take 500 milliliters of 0.25 molar acetic acid. Oh, I need to make, good thing. It's 12 molar. Ooh, yeah, that's tough. How much of this do I need? So what's that? So this is volume. This is molarity. This is molarity, and this is volume. So this is 1, 1, 2, 2. All right. I'm not worried about before and after, but this is a dilution. M1V1 equals M2V2. So if I keep them both in milliliters, and the answers are all in milliliters, 10 milliliters. Oh no, there's 10 liters, 10 milliliters, 0.01 milliliters. 12 point. So we got to be careful. You want to make sure that you're all in milliliters or all in liters. So if I plug this in as 0.25 times 500, but I'm using milliliters, all right, and I can equal 12 times x. So 0.25 times 500 over 12, 0.25 times 500 divided by 12, I got 10.42 milliliters will be my X. So 10 milliliters. Okay. It says you can get by with 10 milliliters. Let's see. Oh, you can't see that. 10.42 milliliters. So 10 milliliters. All right. So that's C. Okay. Now, if you had done that into liters, you'd have gotten 0.01 liters. So you had to be careful of your units there. All right. So then the next one, dissolved salt in water to make a brine solution. That is to say, brine solution is made by water dissolving salt. So, oh man. So the solute is salt. The solvent is water. And the solution is brine. Okay, so dissolved in is my solute. What did the dissolving is the solvent, and the altogether we call brine. Okay, so in order then it would be salt, then water, then brine. D. Okay, that's an interesting one. All right. That it for those? Oh, okay. Here's all our equations if we needed those. All right, so let's pull up chapter 7. It shouldn't be too long. Click the icon. Double click real fast. All right. A lot of equations going on here. Okay, definitions. Let's see, chapter 7. What all did I memorize? Let's see. I had exo is heat product. It's a negative delta 8. Heat goes out. All right, a reaction that absorbs heat. So that's absorbs heat. That's heat going in. That'll be endo. And the change in enthalpy will be plus delta H for endo. All right. As long as I have one of them memorized, I can do. Now keep in mind delta H is products minus reactants. And the H is how much energy is trapped in the bond. And so if there's less energy in the products than there is in the reactants, the extra energy will be coming out. And so that would be exo. Okay. That's how I keep up with that. So this one, absorb heat, then we're looking for endo and positive. Okay, reversible rate is the same as the forward rate is the same as the reverse rate. Then that will be a dynamic equilibrium. Dynamic equilibrium. Dynamic just means we can change. Equilibrium means they're the same. All right, disorder of a perfect crystal at 0K. This is a third law of thermodynamics. So 0K pure crystal, it'll be 0. All right. A catalyst is used to speed up a reaction, and it does that by lowering the energy of activation. Okay, so that's D. And then we got some of these. What are the effects of? Oh man, these shift left, shift right. That's Le Chatelier's principle. My favorite name in all of science. Le Chatelier's principle. Remember, it's like raising water. With your hand, it's going to flow away from your hand. If you lower it, it's going to flow in. So, looking at this, it says adding more H2. So the H2 goes up. This side goes up. This side goes up. It's going to flow down away from that. It's going to shift to the right. So if I take the H2 up, it flows over to the right. All right. Excellent. Same reaction. We're adding a catalyst. Sneaky, sneaky. Catalyst has no effect on the equilibrium. It just helps it reach it faster on going forward, and it's actually faster going backwards usually. So what is the effect? No shift. Catalyst is not a reactant, is not a product, so no shift. Okay, and that's it for 6. Wow, okay. 8 must be really long now. Let's look at 8. 8. All right, 8. Proton, oh man. So I'm gonna come up here, I'm gonna make some notes. Acid. It needs to donate a proton and produce H plus in water. A base needs to accept a proton and produce hydroxide. All right, so acid is a proton donor and it produces H plus. That's C. All right, the following reaction, zinc is serving as a zinc is blank and is serving as a blank agent. So those are always going to be opposite, right? So zinc it's got no oxygen with it. Now it's got oxygen. So my definitions here, oxidation, gain oxygen, lose hydrogen, or lose electrons. The reduction would be opposite of those. All right. So zinc gained oxygen. So if it gained oxygen, it was oxidized. That's good enough. I could say it went from a 0 charge to now it has, I'm going to do ZnSO4 1 times X plus 1 times -2 equals 0. X equals +2. It lost 2. Ooh, can't see it. Too bad. It lost 2 electrons. So if it lost electrons, it was oxidized, or it gained oxygen, it was oxidized. So if it's oxidized, it caused something else to be reduced. Where did it get those? So it lost 2 electrons, right? Where did they go? They went to something else. They went to the copper. But for us, zinc, just treat the word agent as if it flips the meaning. So if it's oxidized, it's a reducing agent. So oxidized, reducing agent. Acid-base neutralization products are, all right, that's memorization. So water and carbon dioxide is combustion. So this one is water and a salt. Water and a salt for a neutralization reaction. Great. There's a great news story of, you like to see it in bonus questions all the time, of a story about one of these big tanker trucks full of sodium hydroxide, and they were worried that it was going to, they spilled it and it was flowing down into a container containing hydrochloric acid. And so the question was, oh no, do we need to evacuate if those two meet? You know what? Well, it turns out that's the best thing that could happen, because all you're going to get is water and salt. You'll get literally salt water. All right, so a pH, a buffer here. Oh man, we got a buffer used to stabilize to 4.5 pH. So 4.5 pH. What is the molarity of the H3? In other words, what is H plus or H3O plus at that? All right, so you can plug this in. pH equals negative log of H3O plus or H plus. You can plug this in 4.5 and do all the algebra. We're not going to do that. We're going to go 10, and our trick was negative and whatever the pH is. And we're just going to plug that in there. So we're going to type in 10 to the negative 4.5 right in my calculator. Now you can't do EE, so I'm going to do second log negative 4.5. I got 3.16 times 10 to the negative fifth moles per liter. All right, so 3.2 times 10 to the minus 50. Now it makes sense that would be close to 10 to the minus fifth. It's a little bit more. All right, good. A blank shows some condition, acidity, or that's an indicator. Right, so and then we have pH of solution of hydronium. Be careful. We had, when we worked these, we had hydronium and hydroxide. You got to be careful between those. All right, and so this one, they're giving me hydronium, which is 2.4 times 10 to the minus 7 molar. So this is literally pH equals negative log 2.4 E negative 7. All right, so type this in, negative log 2.4 second E negative 7. Should be close to 7, and it is 6.6. Which I only went anywhere close to 7 there, so good. So that's C. All right. Now, the acid-base pairing in the following chemical reaction. So let's write this. There's a bunch of stuff going on in this one. All right. NH4 plus CN, and we're going to go to NH3 plus HCN. Oh, the conjugate acid base pairing. All right, so this is my acid. This would be the conjugate base. This is my base, and this is the conjugate acid of that base. All right, so NH4 goes with NH3, and CN goes with HCN. So that's simple. Okay. So this go together, and these two go together. Okay. What is pH of solution with hydronium? Ooh, they sneaky now. Okay, so hydronium, we got to use 10. We're using this equation, H3O plus times OH minus equals 10 to the minus 14. So 10 to the minus 14 divided by 10 to the minus 4 is 10 to the minus 10. And then pH is negative log of H3O plus. This is my H3O plus. And so pH equals negative log of 10 to the minus 10, which is 10. What did I do wrong? Oh, I did hydroxide. Way overthought that. Yeah, hydronium is this. Oh man, way overthought. Good thing that's not an option. This is actually as easy as plug this in, and you get 4. Positive 4, right? And the negative gets rid of the negative. It's just 4. Ah, man, way overthought that. Dang, I didn't have that as an option. All right. So hydroxide is OH minus. It's hydroxide. And hydronium is at H3O plus. And my coffee ran out a long time ago. So, man, terrible. Terrible. All right. So Which of the following is classified as a weak base? NaOH. That's a metal plus an OH. That's a strong base. HCl. It's a strong acid. H2SO4. Johnny was a chemist's son, but Johnny is no more. Johnny thought it was H2O. It was H2SO4. And that is a strong acid. That's a nasty strong acid. Make you itch and burn. Depending on concentration, itch and burn. Make you go away. A couple of drops on your clothes makes your clothes fall off. It's worse than tequila, I tell you what. Don't drink it though. So that leaves us NH3. NH3 is then our weak base, and that was our classic example I want you to know for the weak base. All right, so a buffer is a solution containing a weak acid and its conjugate base. Used to resist changes to pH. It's Le Chatelier's principle at work. So you've got both of them. And so we want a buffer. So here's what this question's asking. Then we want a weak acid and its conjugate base. In other words, what's left after? So H2SO4 is strong acid. HCl is a strong acid. NaCl is salt, and HNO3 is a nitric acid. That's a strong acid. So let's look down here. We've got C2H3OH. That's acetic acid. CH3C. Looks like that if we get fancy. And its conjugate base is acetate, which is CH3C. Oh, negative. We lost this H at the end. But that's our answer, D. Good. That's a little bit tougher than what we usually see on the final. So don't worry about that one too much. But I do want you to know an acetic acid is a weak acid. You should be able to figure out its conjugate base. Oh man, we're almost done. Almost done. I got all that. Let's do chapter 9 then. Chapter 9. Click open. Alpha particle, beta particles. Oh man, we got stuff going on. So nouns and verbs. Okay, nouns and verbs. This is all nouns and verbs. So alpha or to helium. Beta is an electron, so it's 0 mass, -1 down here. Gamma is 0, 0. And we got emit and decay. Tells me it's a product. And we got absorb and capture. These are my verbs. This is reactant. All right. There's my C. Okay. Mass goes up. Penetrating power goes down. All right. So bigger mass, less penetrating power. All right. So alpha particles, huge mass. So charge 2, mass 4. That's the only option there. Low penetrating power. That's A. Okay, that's easy enough. A beta particle, it's medium mass. It rounds to 0, but it has a mass, whereas gamma has no mass. It's just light. All right, so beta particle charge of -1, mass is 0. We got 2 of those, high and medium penetrate. So it's considered medium. Gamma would be our charge is 0, mass is 0, high penetrating power would be D. All right, so oh man, they can just change this alpha beta, and so it gives us whole new questions, same options. Be careful about that. 3 half-lives have passed. What percentage remains? Okay, so I start with 100%. First half-life goes by. There's 50. Second half-life goes by. There's 25. Third half-life goes by. There's 12.5% left. So 3 half-lives is B. Okay. Ooh, what product is formed? So now we're going to be doing some of these products form by beta emission. So I'm going to do uranium, the 235, remember, goes up top. What number goes down bottom? I'm going to go to my periodic table, all right? So come in here. Uranium is down here at 92. 92. So it's down there. And it says beta. So beta, we said, was 0 and -1. Now it's either going to be a product, in which case it's going to be an arrow and then a plus, or it's a reactant, it's a plus and an arrow. So the beta is my noun, and emission and emit, those tell me this is a product. And they are going to want to know what this is. So 235 equals 0 plus x. Make sure you do your algebra. A lot of people mess this up because this next one, 92, is -1 plus y. So this will be 235 and 93. And then I come over here and I figure out what 93 is, and that's Neptunium. NP. Neptunium. It's out past Uranus, right? So uranium, Neptunium. All right. Okay, so then we get. Oh, they even told us the atomic number of uranium is 92, and that gave us so Neptunium D. Which of the following here? And this mine literally says add 3 questions. Hang on. All right. We won't be able to see them over here. Which of the following is an example of alpha emission? All right, so I'm just going to use this to translate. I'm looking for 4,2. So I've got 4,2, and it needs to be a product side. So 4,2, that's C. Now this is add some questions. I'm going to come over here and see what all I got over here. Number 7 added was beta emission. So beta emission, I'm looking for this beta. I'm looking for this 0 and -1. And it's an emission, so this needs to be an arrow. This needs to be on the product side. And so that was A. All right. Looking at the homework there, we had gamma emission was B, alpha emission was C, and then we had alpha capture was D. All right, 8, it said alpha capture. And so 8, you're looking for is 4,2 helium or alpha, and it needs to be on the left-hand side of my arrow. The arrow needs to be pointing away from it. And so that's D. Okay. Hey, man, we did it. We did it. Let's go down. Yep. Okay. Holy cow. It's a lot, right? Well, here's the kicker. Right? When I go back and I count those numbers, that was way more than 65. So yeah, we can do this. Hang on. Click here. There we go. You can do this. I have faith in you. Make sure you have your periodic table. Make sure you have your calculator. Make sure your batteries are up to date on it before you start the test. Print out the helpful equations. Okay. I know it's going to be open book. I know it's open note. But don't spend so much time flipping back and forth. You know, you've got what you have here. Do practice problems so you don't have to stop and say, what kind of problem is this? How do I do this problem? Work through these homeworks, you'll be fine. Remember, I put up some study guides. You can handle this. I believe in you. All right. So I'll catch you on the next one. We'll see if there's going to be any more videos. May just have one throw one up at the end of the semester just to say, hey, we did it. We'll pop cork and some bubbly or something.